to latch, we have here SR latch, get SR latch, which is having the difference between SR latch with the EN. If you still remember, there is EN there, similar to your get D, there is also EN, and EN is normally quite similar to your switch. If you have 0, it's mean turn off. If you have 1, it's turn on. Means that it's going to be a different. So let we directly go to the flip-flop 2D. The biggest difference between the latches and also flip-flop is at this thing. So you're going to see this in terms of your last time if you have SR and you have here EN. But this EN will be replaced with this symbol we call as clock. If you have like this, it is a positive clock rising up, and this one is negative clock which is falling down. There. So we're going to look into 4. If yesterday under lectures we have SR, gate SR, and also gate D. 3 only for the latch. But for flip-flop, we have SR, H trigger D, JK, and toggle. Personally, it's going to be like quite complicated when you play around with flip-flop. But I think in terms of to trigger it, it's slightly easier because you're just going to trigger your output when there is changes trigger on your clock. So here is the flip-flop description, which is going to trigger the input called as the clock. Are you going to trigger your output only when you have a trigger in the input side? And this is the input important, which is rising edge is positive edge or positive clock, falling edge is negative edge, which is negative clock. Here is the picture. You can see it is totally quite similar to your SR gate is R latch, which is you have EN last time. But now it's changed to the clock. You can see here. And this clock, if there is no bubble, we call as active high or positive clock. And we have here is a bubble there. It is a negative clock or falling down. You can see here, this is the part. Here is the part when you have from high to low. This other thing doesn't matter for you. You're going to trigger and output changes at this side only, at this one single line. This one is from low to high. This one is from high to low. So you're going to have only 2 different things. From low to high, this is positive clock, and from high to low, this is negative. And at this side, if you have input, whatever input you have there, you're going to change only at this specific. Not last time for your lectures, you're going to look into at all this side, which is this is 1. If EN is 1, whatever input in between, you're going to see and consider any changes. But for flip-flop, you just look at the specific. If it mentioned positive clock, you just change at this specific value. Although you can see at this side, it also having a changes. But at this point for another input, you're going to look into at this only. So it will trigger at this until you meet another input, another clock, rising up clock or positive clock, until you meet another positive clock. So let's take a look example here between the latch. If you have here similar input S and R, and also you have either EN for your latch and clock for your flip-flop. First, we look into the latch first. For the latch, we're going to look into 1, 1, and 1. So any changes of your input at this specific point, I'm going to look and consider the trigger for my output Q. So I'm going to do like this. So you can see here in between I have another changes. So I need to consider also. Again, as mentioned yesterday, the dotted line that already created here, it knows the answer. So that's why it didn't put everything. But I suggest you to do the dotted line for any changes at your input. So another one, of course, 0, it doesn't matter because you're not going to look into any 0. 0 is no change. And another one at this point, you're going to see from here to here. Okay, the value, I just want to see inside, okay? Yesterday, you already looked into example for all. So here is 1, here is 0. Here is 0, here is 0, here is 0, here is 1. And then another one is 0 and 1. Okay, we have S, R, E, N. If it is 0, nothing changes, no change for your Q. If it is 1, 0, 0, 0, 1, 1, 0, 1, 1, what happened is no change. Dah lupa dah. This one is reset. This will be set and this will be invalid. Okay. Now we have here the beginning is low. From low, I have this part. I need to see the input. S1, R0, I'm going to change to set. Set is 1. So I stop here. I can see this is 0, 0, 0 for my N. So nothing changed here until I meet another 1. I meet another 1 here, and my 1, I have several changes in this. First is 0, 0. What is 0, 0? No change. So I just continue, no change until I have another here, 0, 1. 0, 1 is reset. So what I'm going to do, kenapa I lukis kat bawah? This one is flip-flop. Okay, here, no change. And then another one is going to be reset to be 0. So here will be 0, 0, 0, 0, no change, no change, no change until I meet another 1. So another one, my input is 0, 1, it's reset. So still continue reset until here 0, 0, 0, no change, no change, no change. That is my latch. Now I look into my flip-flop. My flip-flop is similar things. But wait, is there any table? No. Not yet. After this, we're going to look into the SR lash flip-flop. There is a table which is totally similar to your SR get SR lash. Okay, now you can see here, this is our flip-flop. The only difference is our clock. We have SR 0001 1011, which is similar, and C apa tadi? Reset and set and invalid. Okay, we have clock. Our clock now is rising up. Positive clock. Positive clock, positive clock, positive clock, positive clock. The rest I'm not going to consider. So at this specific point, the dotted line is already created for me at this specific point. I have 3 only. I have 3. At this point, my S is 0, my R is 0. I go for next. At this point, I have 0, I have 0 here. At this point, I have 0, I have 1. So what will happen? In the beginning, I have low and 0, 0. Oh, sorry, this one is 1. 1, okay? 1, 0. 1, 0 is what? 1, 0 is set. So I'm going to change here. At this line, I'm going to change to be 1 or set. And the rest, I'm not going to consider anything, not going to change anything, because I'm going to trigger only after I meet another clock. Until here. I need to consider my input. 0, 0. It said no change. So I continue until I meet another clock here. Now is 0, 1. It is reset. So I'm going to continue until I meet another clock. Then I'm going to trigger whatever here. So although you have similar input, similar for your clock and end, but your output will be different for latch and flip-flop, because N will be covered for 1 here. So any changes at this side, at this column, it will be considered and change anything here. This one here, if there is any changes in between, you need to do a changes similar to this part. But but you can see here, for the clock or flip-flop, you just change and trigger at this single line, single line, single line. That's why your output will be totally different. Although you are referring also at the similar table what you learned yesterday. So now, this is your SR flip-flop. Just now I already showed you. You can see here, if this picture, it is a positive. You can see the table is totally similar, which is 0, 0, no change. 0, 1, reset. 1, 0, set. 1, 1, invalid, similar to your latch. Only at this part, it is EN and it's 1, 1, 1, 1. Remember back? Yesterday, you already learned. So, totally similar, only the different when you're going to trigger. So here there is another example. Positive edge here. Positive edge here, you're going to see you have this. At this line, you're going to draw the dotted. It's already created for me. And I put the value. Here is 0, here is 0, here is 1, here is 0, here is 0, here is 1, 1, 0, 1, 0. Now, at the beginning, let's say I have starting with low. And SR clock. So I do this because I want you to remember. I repeat several times. Hope that you will remember. This is set. This is 0, reset. And this is no change for your Q. So this is the table that you need to refer. Now let's withdraw. At this first clock, we have 0, 0. What is 0, 0? No change. So you will directly continue, ya Allah. Directly continue until you meet another next trigger of your positive clock. So here you look 1, 0. 1, 0 is set. So you go up and then you continue until you meet another next. From here you check 0, 1. 0, 1 is reset. So you reset back and continue until you meet another clock. Another clock is 1, 0, which is set. You're going to continue your set until you meet another clock. Another clock is 1, 0, means that set. You continue until, finish. That is how you can draw. Here there is example without answer. Let's redo slowly. You can see here it is a positive edge. It's already draw for us positive edge. And initially it's reset means a low for your Q. And what else? SR flip-flop, which is you need to refer to the table of SR, CLK, 0001, 1011, invalid, set, reset, no change, Q. Now, we're going to look into our clock already dotted, okay? So I'm going to fill in the value only. Here is 0, here is 0. This one is 0 and 1. 1 and 0. 0 and 1. 1 and 0. 1 and 0. So let's take a look. 0 and 0. No change until I meet another trigger. Another clock. 0, 1. 0, 1 is 0 again. So I continue until I meet another clock. 1, 0 is 1. Until I meet another trigger. 0, 1 is 0. I meet again. Here is 1, 0 is 1. 1, 0 is 1. So I can finish, and my Q bar always toggle thing. So I can easily draw this. So here is the answer. And you can change everything here to the table. So any question for SR flip-flop? Any question? Understand everything? So we move to another one, which is D flip-flop. So for D flip-flop here, it is going to be follow the D latches table. D latches table last time. If you still remember, if EN equal to 1, D is 1, your Q is 1. D is 0, your Q is 0. Totally similar, only now it is clock, whether it is up and also down. Let me see here the example. You can see the table is totally similar. If your D is 1, your output will be 1, which is set. If it is 0, then it will be 0 for a reset. Now you can see here, you got positive clock, and at each single line here I put the value. Here is 1, here is 0, here is 1, here is 0. So from low, let's say this is the initial value, you're going to set as 1 until you meet another positive clock. You're going to follow the D, going to be 0 until you meet another. You're not going to change each between, okay? You just change and change your output at this positive clock. And then another one is 0 here. Let's see another example. Okay, this one is JK. So yesterday I said this one is much more easier because you just need to remember 2 input and 2 output. 1 to be 1, 0 to be 0. So it's slightly easier rather than like JK, SR. You need to have 0, 0, 0, 1, 1, 0, 1, 1, isn't it? So let's proceed with our JK here. For our JK, you can see it is basically quite similar, but the difference is only JK, no invalid state. If SR, you can see 0, 0, no change, 0, 1, reset, 1, 0, set, 1, 1, invalid. But our 1, 1 for JK, it's not going to be invalid because no invalid state, it will be toggle. So this is the only thing, differentiation between JK and SR. So if let's say you're going to have this table, 0, 0 is going to be no change, 0, 1 is going to be reset, 1, 0 to be set, and 1, 1 to be toggle. So this one is positive clock. For positive clock, you're going to draw positive, 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 positive. Now, at this specific point, what is the value? 0, 1. At this specific point, what is the value? 1, 1. At this specific point, 1, 0. This one is 1, 1. 0, 0. 0, 0. The rest is all 0, 0. Okay. Now here, starting with the low, assume is to be low, until we meet our first positive clock there. We have 0, 1. What is 0, 1? Is a reset. Reset means 0. So I will continue until I meet another clock. 1, 1. 1, 1 is what? 1, 1 is toggle. If previous output of Q is 0, I'm going to toggle to be 1. If previous Q is 1, I'm going to toggle to be 0. So previous one is what? 0. I'm going to toggle to 1 until I meet another clock there. Another clock is 1, 0, which is set. Set will means by 1. So I'm continue until I meet another clock here. Another clock is 1, 1. 1, 1 means toggle. So previous is 1. I'm going to toggle to 0 until I meet to my another clock here. 0, 0, no change. I continue until I meet another clock. It is 0, 0 again. I continue until I meet another clock, which is 0, 0. No change again. Here is I meet another clock. Still 0, 0, no change. I'm going to continue. No change again. And this is my answer. So the hint is you need to remember this table. How are you going to derive? You can try using your dissimulator. Put here also, then you will come out and get this output. So what else? Okay, this is another example. Let me draw for you. We have initial is low. We have positive clock, positive, 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 positive. And at this specific line, positive line, I'm going to put the value. So it will easier for me later on. Here will be 1, 0, 1, 0, 1, 1, 0, 1. Correct me if I wrongly label, okay? Then here I have my table JK00011011. This one is toggle, this one is set, this one is reset, this one is no change for the Q. 0, 0, I'm going to have no change and I continue until, ya Allah, until I meet another clock. 1, 1 means toggle. So from 0, I'm going to go for 1 and I continue until I meet another clock. 0, 1 means reset. So I'm going to reset it to be 0. And 1, 0 will be set. I'm going to set until I meet another one. Similar, set also until I meet another one. Clock. 1, 1, it will be toggle. And 0, 1 will be reset. So I continue. So this is my answer for my Q. For Q bar, of course, you just toggle everything for following your Q. Okay, next. This one is negative. That is the only difference. Let me draw the negative first. Negative clock, and the rest will be similar. 1, 1, 0, 0. Here will 0, 1. 1, 0, 1, 0. So I draw. Initial is low. If 1, 1 is going to be toggle until I meet another clock here. 0, 0, no change. Here will be 0, 1 is reset. I continue until I meet another clock. 1, 0 will be set. Until I meet another one is set also. So this is my answer. See, just 1 minute you can finally get the output. But the key is you need to remember the table. Now we have another one is our T flip-flop. What is T flip-flop? T flip-flop is like a toggle. When you have T equal to 0, alhamdulillah, no change. If T equal to 1, it's going to be toggle. This one is quite similar to D because you just need to remember 2 output only. No change, toggle. Last time for D, if D is 0, your output will be 0. D is 1, your output will be 1. Simple. Similar to your T, also simple. So let's take a look into example here. You can see when you have 0, you have whole or no change. When you have 1, whatever clock is there, you're going to toggle. So let's say in this example, it is a negative clock. So that's why you are pointing down there and put the dotted line. Here is the value at the specific line. Then from initial 0, when I see a 0, no change. I will continue until I meet another clock. And it will be 1. 1 will be toggle until I meet another clock. Here will be 0. 0 means no change. So I will continue until I meet another clock here. I have 1 means I'm going to toggle. So this is my answer. Next one. I have, okay, I'm not going to touch this. Any question for this flip-flop before we go for the preset, before we go for clear?
Doctor, can you explain the last truth table, please, again?
The T1.
Yeah, this one.
Okay. For the T flip-flop, it is a toggle flip-flop. And when you have CLK positive, or maybe it is a negative clock, you have T. T will be whether it is 0 or 1. Your table for your Q will be 0, no change. 1 will be your toggle. Over here, you can see at this example, you have negative clock. That's why you are pointing down here. And you are given with the value of the input T there. And each of these, I ask you to draw the dotted line, and at the specific line, you need to put the value of T. Here T is 0, here T is 1, here T is 0, here T is 1. And from here, let's say the beginning of initial Q is 0. You're going to continue until you meet a clock, isn't it? Depending on your flip-flop. If the clock is positive, you're going to stop until here only. But now our question is negative, so you're going to continue until negative clock. At this clock, you check the input of T. Input of T is 1. So you refer to your table. 0 will be whole or no change. That's why you will continue no change until you meet another negative clock here. And you refer to your input at this line. Now T is 1. 1 will be toggle. So you're going to change from 0 to 1. You toggle and you continue until you meet another negative clock. At this line, your value is 0. And if 0, there is no change. So you're going to continue until you meet another negative clock. And from here, you can see the value is 1. 1 means toggle for T flip-flop. So you're going to toggle from 1 to 0. So you're going to continue until you meet another negative clock, negative clock. Okay, can you understand?
Yeah, I got it now. Doctor, thank you.
Okay, any other question? Any question related to your all flip-flop here? So you need to try to play around with the waveform, because there will be always been asked last time in your previous subtopic, you play around with your boolean, you play around with your true table, you play around with chem maps. Now after you go for 7 until the rest, there is a lot of timing diagram that you will meet. So you need to generate your own Q output. You need to generate your own output of wave. Okay. So later we will touch our preset and clear. So this thing is about your unsynchronized and synchronized. There is not too much to cover, because this one is very small one, but it will be much complicated because you're going to consider from one to another. This is highest priority. You need to check preset and clear first, whether it is 00 or maybe it is 01, clear. 10 and 11. So there is a table for this. If 00, what will happen? If 01, what will happen? If 10, what will happen? If 11, what happen? So there is something, let's say for this part. 11, it will be synchronized. What meaning by synchronized? You're going to look at your clock and your flip-flop. See, you can see synchronized input. So you're going to consider next thing. This one we come to see. Okay, here. You can see you have JK, you have clear, you have preset. So there is a lot other thing that you need to consider. First, you need to consider of clear and pre. All the input value, you need to check. If it is 1, 1, clear is 1, preset is 1, like at this stage. Here until here, at this part, this is 1 and 1. So you're going to look into your JK. The rest, if it is not 1 and 1, there is specific things that you need to remember. If it's like 0, 1, it's going to be set. If it is 1, 0, it's going to be reset, and etc. So that's why I said there is much more thing that you need to consider after this. First is clear and preset. Second, you need to check whether the input is what, and then you need to check your clock. Then you need to check your input value. So there is a lot of step by step. Before we going to touch this synchronized and unsynchronized, I want you to be familiar with the timing diagram for the basic latches and also flip-flop. When you're done with this, it's easier for you to understand why after we have this pre and clear at the point of 111 here, why at this part we need to consider the clock and also the input of JK. At this point, you can see we didn't refer to any clock. We just look at the pre and clear. So every single things you need to have understanding of your basic flip-flop and latches first. After this, it is just a few slides only because it's very quick one. And there is extra note for your master slave. And maybe this morning I teach already this part, but I think some of them are confused because it's too fast for them just learning for the lectures, just today learn for the flip-flop. Suddenly there is a lot of things to do here. Before you can go further, I want you to try every single exercise in this flip-flop and lecture. Is it okay? So if there is no question, you have a lot of time. What you need to do is conduct your group, your lab group. Try to find your scenario for your project report. For those who still not yet submit your lab 2, please contact me and give me a reason why you did not submit your lab 2. And the rest, all of you, please proceed with your group project. Go to the Google, find the scenario, and maybe if you have the module and ebooks last time, e-module that you already bought, you can go for module 8. In the module 8, then you can see, oh, there is a correlation, there is example in what parking lot. What else? There is a few example there on the counter. Synchronized counter. What else you were given? The control gates, the generate timing bomb, the generate clock. So go and take a look into your module 8. So there is also example for the basic scenario. So you decide first with your friend without waiting for us to finish, like module 8, module 8A, module 8B. You need to start with your project. Is it okay? And please make sure whatever you find in the Google, you save as a references, because there is a part for you to write the references, right, when you Google and everything. So I think that is for today. Please make sure you check your e-learning. I will upload our class. I think last time I already upload into the YouTube, but I forgot and I didn't have time yet to upload to the e-learning. So if you can check your e-learning, maybe there is no update about the video, you can go for the YouTube and found your video there, okay? Thank you for your participant. Please stay safe. I think everyone already scanned the QR code. Meet you again next week. No, not next week.